And it's time for me to challenge myself yet again and use nothing but math to try to solve a problem. And the problem here is that I want to launch this beautiful spacecraft to this little object right there. So, that's the moon and this is my spacecraft. Doesn't sound very difficult yet, but I'm going to challenge myself by doing this completely in the cabin mode and using the F2 mode as well, where I will hide everything. This is all is going to be hidden, and I'm going to be playing as one of the characters inside this capsule. And how I'm going to do this is by using nothing but math. So I'm going to actually show you the formulas that I'll be using to calculate things. And essentially, this is a recreation of Kerbal style Apollo mission where we're going to be launching 3 astronauts or 3 Kerbonauts to the moon using nothing but math. Welcome to What the Math. My name is Bill Kerman, and I'm the member of Kerbal 1 mission. This is the expedition to the moon. We're going to make sure that we land on the moon safely by using this beautiful spacecraft, which I am inside of right now. This is my friend Bob. Hi, Bob. Say hi, Bob. Say hi, Bob. Okay, I think Bob is too busy. Valentina, where are you? You're somewhere in the back. I can't really see you. Anyway, so we're ready to fly this thing. We're going to be using only these devices right here, and we're going to try to launch ourselves into space on this beautiful spacecraft. Alright, so let's check everything. RCS on, SAS on, and let's begin our mission by cranking this up all the way. And 3, and 2, and 1, and launch. Excellent. Alright, looks like we're flying. So we're going to try to make sure we're not going too fast. So I'm going to be watching my speed. And right about now, let's slow down a little bit. We're going to crank this down and make sure that we're not going a little bit too fast or faster than we should. Let's begin our gravity turn. This is currently altitude of 2 kilometers. And we're going to start tilting a little bit to the 90-degree angle here and slow down a little bit more. I don't want to go over 200 meters per second because this will make my spaceship flip, unfortunately. And here, we're going to slow down even more. Alright, excellent. The altitude is 6 kilometers. We should be tilting a little bit more. I cannot see the ground anymore. I only see the clouds. And so far, everything is going as planned. At an altitude of about 10 kilometers, we're hoping to have a pitch of at least 45 degrees. Okay, we're not there yet, but we're getting there. I think the altitude is just fine. The pitch is just fine. We're getting a little bit of interference here from the airflow that is making us flip a little bit, but that's why we need to slow down. Okay. Speed is almost 400. Altitude is 15 kilometers. We should be pitching even more. And alright, a little bit more. I can see the ground and the ocean. Altitude is almost 20. And I think our first stage is going to run out of fuel pretty soon. We're going to have to listen to the engines. As soon as we hear less room from them, this is when the engines are out. Okay, this is good. This is looking good so far. Looking good so far. Okay, here we go. And release. And increased throttle full speed. We're gonna try to get as much altitude and speed as possible. We're currently at almost 30 kilometers. Going at 1 kilometer per second. I can see the water and the clouds. Oh, okay. What was that? That was not a good sound. What was that? What was that? Okay, we're burning a little bit, so we have to slow down. Burning up. That's not good. 30 kilometers. I think the speed is a little bit too high. And I think Bob is not doing so well. That's okay. Bob, you okay? Bob. Okay, Bob is in meditation mode. Alright, we're flying fine so far. So, okay. Now we need to figure out how high we want to go. I was planning to go to about 80 kilometers. Bob said 70. I said 80. Bob said 70. I said 80. I think I'm going to go with my thing because I'm the controlling person in this spaceship. And what we're going to do is we're going to try to launch ourselves to 80 kilometers. And at that altitude, we're going to have to have our orbital speed. Now, this is the formula I'm going to be using for this. And the orbital speed at 80 kilometers should be approximately 2,279 meters per second. Now, here, GM stands for the standard gravitational parameter. And on Kerbal, this standard gravitational parameter is 3.53 times 10 to the power of 12. Okay, I need to slow down. Okay, I think I may have overshot this a little bit. It's very likely that we actually are going to be entering a very, very high orbit in this case, which is not good for us. Anyway, so that's okay. We're going to figure this out as we go. So the altitude is still increasing. Now, what we're going to do is we're going to wait until we reach apoapsis and then burn at that apoapsis until we can reach the necessary velocity for a circularized orbit. Unfortunately, the spaceship is very difficult to control right now because there is a lot of weight on it. So we're going to try to use RCS here and position ourselves toward the... okay, I think we're getting there. Are we getting there? We're going to position ourselves toward the prograde vector, which is the yellow circle. And at this point, we're going to burn and... Okay, let's see how high we get. We're almost at 70. We're still climbing up. We might be getting to 80, but we're not sure if we're going to get to 80 or not. But the orbital velocity here is lower than it should be. So we're definitely not in orbit yet. We're definitely going to be returning to Kerbal if we don't increase our velocity, which means that we need to make sure that as soon as this is sort of leveled, we are going to burn and get to a circularized orbit. So I'm going to be aiming at about 2300 meters per second. So this should be 2300 as soon as this is leveled up a little bit. Okay, so it's going to be a little bit higher than 80, it looks like. It's about to hit 80. And the hands on that clock are still going up. So we might be actually at a slightly higher orbit than anticipated, which of course will set us back a little bit because our calculations are a little bit wrong. But here we go. This is officially 80 kilometers. We're still not at apoapsis. And we just need to increase our speed by about 300 meters per second. But it looks like this is leveling out, so we're about to reach apoapsis. And apoapsis is, we're currently at 82. 82. Going to 83. Alright, that's good. And I think Bob is still shocked. Oh no, look, he's moving. Bob is okay. Bob is okay, everyone. Alright, so we're at 84-ish. We might be getting to close to 90, but I don't think we'll get to 90 exactly. And let's position ourselves toward the vector of velocity. And right about now, so okay, 85. Looks like it's, no, 84. 84. We're at 84. Let's start increasing our speed. I'm going to increase it to 2300. Or 2250, 2270, 2279. That's what it should be, 2279. 2279. And that's, of course, by calculating, or by using this formula I'm showing you, or I showed you before. 2279. Make sure that we don't go too fast. We shouldn't be going too fast. And 2230, 2250, 2260, 2279. 8. Okay, that's good enough. Let's see how we go. So we're actually falling right now. That means that we have passed our apoapsis. And we haven't reached the circular orbit exactly. And we're falling pretty quick. So we're going to try to circularize this by finding our apoapsis again. And at that point, we're going to try to burn a little bit more until we have a relatively circular orbit. And we can tell if it's circular if this arrow is not moving or this hand is not moving at all. Turns out we're actually a lot higher in apoapsis than we thought. It's 96 kilometers apoapsis right now, and our speed is 2236 meters per second. We're going to increase this to about 2254, 55. This is what I have according to my calculation. And we've also selected Moon as the target now because we need to actually start planning our Moon transfer. And the only way to do this is for us to basically use the nav ball and try to aim at the Moon. Okay, this circularization business is a lot more difficult than I thought it would be, so we're just going to go with it. Let's separate our last stage, and we're just going to try to transfer to the Moon using all our mathematical knowledge and the fact that we're now at an altitude of approximately 93.5 kilometers from Kerbal. Okay, so it's time for us to start reasoning about how we're going to transfer to the moon. What we're going to do is we're going to use this formula right here that shows you what's called a phase angle. A phase angle is the angle needed to start our transfer maneuver. And basically, if this is the moon right here, we have to make sure that we're kind of behind it by a certain phase angle. And so here, if you plug in the numbers into this formula, where h1 is the height above Kerbal, and for us currently it is 91 kilometers, but we're going to go with maybe something in between periapsis and apoapsis. I have a feeling it's somewhere around 92. So this is going to be our h1. h2 is the distance to the moon, and here it's actually 12,000 kilometers. And we actually should be using meters, not kilometers. So height 1 is going to be 96,000, height 2 is 12 million, and radius is radius of Kerbal, which is of course 600,000 meters. If you add this all up, use the exponent of 1.5 and multiply this by 0.5, you're going to get, and also then multiply this by 360 degrees, you're going to get 69-degree angle, which is what my phase angle is. So in other words, I should be approximately 69 degrees behind the moon when I start my burn, and I'm going to be burning toward my vector of velocity. Now this is where we should be burning, and so let's actually try to find where 69 degrees is on the nav ball. So what I should be aiming at is, so this is 10, this is 20, 30, and okay, so just to make this a little bit more clear, we're looking at this is going to be 0 right here. 69 is this way. We're going to measure 69 degrees, and since we can't really see 69 here, we're going to go for 70. And I think 70 is right about this location here. So this right here is about 69 degrees. And because our burn is going to take us about 90 seconds, and because the moon is actually, because of our orbit, the moon is changing position relatively quick, we're going to start burning when the moon target is approximately at this location. So because the burn is going to take us this long is going to actually move through 20-degree position here on the nav ball. So we're going to start burning when it's approximately at this location. And now here's the question: should we be aiming, or should we be waiting for this, which is of course representing the position away from the moon, or should we be aiming at the moon itself? Well, of course, the answer to that is that we should be aiming at the moon itself, and so we're going to go for the actual circle. And so when this circle thingamajiggy gets to, and this is of course the Kerbal scientific term for it, it's called thingamajiggy, when it gets to the about 30-ish degrees above the horizon, which is the location that's right here, right about here, we're going to start burning. And so the next question is, of course, how much should we burn and what velocity should we have, or what should be the delta V here? What is the change in our velocity between what we have right now and what we should have for us to escape from Kerbal and initiate what's called, in scientific terms, Hohmann's maneuver. This is when you transfer your orbits from a lower orbit to a higher orbit. And here is the formula that you can use to calculate this. It looks a little bit more complex. And here what you see is, so the first letter, mu, this is of course the standard gravitational parameter, which as I mentioned before is 3.53 times 10 to the power of 12. Radius 1 is the distance away from Kerbal that we currently have, and this is of course 92,000 meters, I think. And then you have to divide them and square root them, and R2 is 12 million meters. So here what you'll have is 24 million divided by 12,900,000. It took me a while to try to calculate it in my head. And square root of that, -1. And I think the answer to this is approximately 850-ish meters per second. I'm saying ish because we're still going to be not very accurate. And so for this particular maneuver, we made sure that we bring just enough fuel in our third stage. And we currently have only 862 delta V in that stage because this is all we took with us, just to make sure that we use that third stage to to do nothing else but transfer to the moon. So what we're going to do is we're going to initiate the burn right here and burn as soon as the little circle thingy gets to 30-degree position. And this should hopefully set us on intercept maneuver with the moon. And there are, of course, 3 things that could happen, right, Bob? That's right. The first thing is that we might actually overshoot the moon and come in front. We can also end up coming from behind, and we may also just crash into it. We're ready for all 3, which is why we have another 2 stages for us to do a little bit of maneuvering as we're approaching the moon. So we're going to try to figure things out as we get closer to it and use our altimeter to try to figure out if we're actually crashing or coming from behind or coming in front. Meanwhile, though, let's actually position ourselves toward the prograde and wait for the circle to get to this position right here. All right. Bob, ready? We're reaching the phase angle of 69 degrees, or actually this is going to be more like 59, but we need to start burning and burn all of our fuel from the 3rd stage to try to transfer to the moon. And this is going to be a little bit difficult because this ship is going to shake a lot. All right, ready? And launch. And here we're not going to be looking at the speed because basically we're burning the entire fuel tank that we have. And we just have to make sure we're going toward the vector of velocity. And so we're going to be manually centering ourselves toward it. And as we're doing this, we can actually look at the planet and look around. This is all cool. As you can see, speed is increasing. This is good. By the time we finish burning, the moon should be at about 10 degrees above or below horizon. And at this point, we should be on the intercept with the moon if everything is correctly calculated. And if it's not correctly calculated, I'm going to be blaming Bob because he is the mathematical genius behind all of this mission. I am just a pilot. Do not blame me. All right, good. Everything's going good so far. I'm not sure how much fuel we have left, but this velocity should be over 3,000 meters per second by the time we finish burning. And something gets things are getting a little bit too shaky. It's a little bit too difficult to manually control this, but we have no option. And my hands are steady. Right? Where's my hands? Where are my hands? I don't see my hands. My hands are too short. Anyway, so let's keep burning. And we're almost there. I think we're almost finished burning this. As you can see, the altitude has started increasing because we're now escaping from the lower orbit to the higher orbit. And if everything goes well, we're going to be on the intercept with the moon. We can only find out about if we're actually successful by the time that we actually reach the moon's orbit. Okay, finished. Game over. All right, so all we can do now is wait. We're going to release the last stage and shut down the throttle, and we can just wait and possibly actually disable everything else because we're going to try to save electricity here. And we're just going to wait and see what happens. If once we're approaching the moon, we're going to be looking at the altimeter, and it's going to start decreasing, obviously. And as it's decreasing, we're going to try to see if we're crashing into the moon or approaching one of its, or basically approaching periapsis, at which point we're going to try to land carefully. All right, so now let's just wait a few hours and we can go to bed, right? That's right. Correct your helmet and let's go to sleep for a few hours. You know what? It turns out we've overshot the moon by about 1,000 kilometers. I'm going to unfortunately blame Bob on this, and we're going to have to talk about this on the way back home. But here we're about 1,000 kilometers away from the moon. You can see Kerbal and also the sun in the distance, which is of course absolutely beautiful, but it doesn't change the fact that we need to do something about it. I've engaged the last stage, and what we're going to do is we're going to decrease our orbital velocity by about 200 meters per second. Because we're so far away from the moon and we're going really fast, we're actually going to end up probably returning back to Kerbal. So let's decrease this by about to about 80 meters per second. This is the velocity, and you can use this formula once again that you see on your screen to try to calculate orbital velocity here. We're going to be aiming at about 80. Because what we're trying to initiate now is a suicide burn on the bright side. You can see the sun is right there. If we actually burn this to about 80, we're going to be landing on the bright side of the moon, which is absolutely perfect, which is what we want. We're also going to engage our gear right now, gear up or down, so that because we need to start landing, and we're going to forget this later anyway. All right, initiating engines right now. Let's slow down to about 80 meters per second. And because of the distance that we have currently, we should be landing on the moon relatively fast. But I think, or I hope, we have enough fuel for us to land safely. So this should be about 80 meters per second, and this will give us just enough orbital velocity to gently land on the moon. Okay, 81 is good. And so if we've calculated everything correctly, we should now be actually very gently suicide burning toward the moon and possibly crashing or crash landing, but hopefully not. So what we're going to do now is we're basically going to just aim toward the retrograde vector, and as soon as this altimeter starts decreasing a lot, and as soon as our orbital speed increases to about much higher values, so somewhere around 400, 500, we're going to start slowing down and landing on the moon. Well, here's Kerbal, and here's the moon. It's a lot closer to us than it used to be, and it's actually approaching relatively fast. We've decided to wait until about almost 600 meters per second before we start suicide burning, and the altitude is decreasing really fast, so it's time for us to actually turn toward the retrograde vector and begin our landing maneuver. So the way it's going to be done is we're going to just manually position ourselves this way. And right about now we can start slowly burning, although the speed, the altitude is actually relatively high still, so we can still wait a little bit. But you can see the moon is actually approaching us really fast, so I'm getting a little bit worried, so we're gonna start burning, I think. We're actually going to reposition ourselves so that we can actually see the surface a little bit better, and I think this is pretty good because we want to make sure that we're not approaching the moon too fast. And let's decrease the velocity at about 30 kilometers. We're going to decrease this to about 200 meters per second. And just making sure that our gear is on, everything is on. Okay, perfect. So at this point, what we're going to do is just watch the altitude, watch this right here, and of course watch our speed. So as soon as this starts decreasing, we need to make sure we blast our engines. Hopefully we'll have enough fuel to land very gently, and if not, we may have to rely on our last stage. So 30 kilometers is when we're going to actually start decreasing this to 200. And I have a feeling that this is obviously not accurate. This is the most accurate apparatus I have. This will show us the exact altitude above the surface. This unfortunately shows us only the average altitude above the what would be called the sea level, even though there's no actual sea on the moon. All right, so we're slowing down. Let's slow down to 200 and stop. And so we're gonna wait until 10 kilometers and slow down again. You can see the moon is approaching relatively fast. We can kind of turn around and see what's up, what else is up here. And all right, we're looking good so far. I think this descent is going really good. As long as nothing goes wrong, and as long as we don't actually miss our point of when this arrow starts decreasing in altitude, and of course, as long as we don't run out of fuel. Well, unfortunately, there's no way for me to check how much fuel I have. We have to rely on eyeballing things. But in about 10 kilometers, as soon as this gets to 1, we're going to, as soon as the big hand gets to 1, we're going to start slowing down to about 100 meters per second. And it's mark time to do this at 100 meters per second now. I have a bad feeling there's going to be a fuel shortage really soon, but hopefully not soon enough. This is not moving yet. Oh boy, we're really moving closer to the surface now. Have to start being really careful. Let's keep this at about 90 for now. Yeah, I can definitely see the surface coming closer and closer to us. I see the rocks. That's a good sign, or maybe a bad sign. And here we go. Radar altitude started to show us that we're now at a distance of about 2 kilometers, even though this actually says 6 kilometers, 7 kilometers. The actual distance is about 2. I'm going to start our descent a little bit slower. 41 meters per second is about as comfortable as I feel about this. And here we go. Okay. Rocks are visible. We don't really need to look at anything else except for the radar altitude meter. And so here, as soon as we get to 200 meters, I'm going to start slowing down a lot more. Actually, probably 300 meters. is when I'm gonna start slowing down a little bit more. And okay, we're moving a little bit too fast. Let's do it. I think 20 meters per second is a little bit of a safer descent. And oh, we're landing inside the crater apparently. Ah, that's interesting. Okay, let's slow down, and 7 meters per second. That's perfect. That's actually really, this is a perfect descent speed. Also means that if we end up running out of fuel right now, we're not going to be crashing too hard. 8 meters per second. Okay, that's a little bit less safe. Okay, it's going great, man. Mr. Bob. It's going great. It's going really, really good. I like this descent so far. As long as the fuel lasts. If we have enough fuel, we'll be fine. If we don't have enough fuel, we're not going to be fine. 200 meters. To increase our speed a little bit more. Decrease our speed a little bit more. And 7. 6. Perfect. 5. 4. And this is what it looked like for other astronauts out there that actually landed in such a manner as well. And here we go. There's a rock right there. We're going to use this as a mark. And good. Turn off the engines and landing. Excellent. Touchdown for Kerbal 1 mission. We've officially landed on the moon. We can now go outside and do a bit of exploration. Ready for this, Bob? Let's go outside and look around. And look at that. It just so happens we landed right next to this arc that is infamous on Kerbal. This is actually by accident. We landed on this arc. Someone actually showed me this before. I've never really seen it myself until now. Let's go and see what this arc is like. And here comes the beautiful arch. I'm going to call this Bill Kerman Arch. We're going to plant a flag on top of it and claim it for ourselves. This is going to be our beautiful new discovery. And let's just go on top and make sure that we have a beautiful location for us to take a picture of it, of all of this. And it's very interesting how this is completely by accident. All right, here we go. Oh, no, 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 no. Oh, that is not good. That is going to hurt on the way down. Okay, here comes the ground. And owie. Right on my head. Excellent. All right, let's try this again. All right, I finally made it to the top of Bill Kerman Arch. And I don't even know where the spaceship is anymore. It's somewhere over there. I think it's right here. And we're going to have to return to it in a second. But let's actually plant the flag first. Claim this for ourselves and return back to Kerbal, which is somewhere out there in the universe. There it is. There's Kerbal. We're going to return to it in a second. But let's plant the flag first. I claim this arch for Kerbal race and space and so on and things of that nature. I have nothing else to say because I am the space scientist. I'm not a writer. All right, here, let's return to Kerbal 1 and take off and try to return back home. And so this is the Kerbal mission. Here we have the landing stage right here, which is going to separate as soon as we start taking off. And then this last part will return us back to Kerbal and then separate. And underneath all of this, there's a heat shield and of course 4 parachutes that will hopefully, if everything goes right, return us back home in the matter of a few hours. So let's actually return back. We're going to get inside the spaceship. Where's the doorway? I'm gonna get inside the spaceship and, of course, set our course for the mission back to Kerbal. Grab onto this, and get inside. Alright, so we're going to initiate our last maneuver, and here what we need to do is we have to go away from the moon, and we also have to make sure that we're accelerating in the opposite direction of its orbit, which is going to be relatively challenging to figure out. So I may have to actually go outside and try to see if I can find where west and east is here. And essentially we're trying to return to Kerbal by burning for... first of all, we're going to reach the escape velocity from the moon, which is used... you can find using this formula, and it's about... it's just over 600 meters per second. And then we need to initiate a Hohmann maneuver to try to descend into the periapsis that is going to cross with the Kerbal's atmosphere. And here, for that Hohmann maneuver, we need to basically use about 200 more delta V. So in total, we're going to be spending about trying to reach a speed of about 800 to maybe 900 meters per second. It doesn't have to be accurate because The last step here is to crash back into Kerbin and use heat shields to slow down. This is why we brought the heat shields. And so let's think about this. So we're currently pointing almost up, but a little bit away from up toward about 275. So I think I should be going this way. I think this is where I'm going to be going. And this is, of course, the 90-degree angle that we use to take off from Kerbin as well. So let's see how this goes. So let's actually try to launch our spaceship. And this is really the hard part, trying to figure out which way you're going to be pointing yourself so that you don't actually accidentally go in the wrong direction. So let's launch the spaceship. And here we go. And point toward 90 degrees. Is that 90? I think so. And we can actually see everything on the surface as well. And as we're taking off, we're going to listen to the engines because the last stage is about to run out of fuel. As soon as that happens, we're going to... there we go. This is going to release the last stage along with the gear and everything else. And now all we need to do is take off and basically try to move in this direction. If everything is calculated correctly, we should be going away from the moon and moving in the opposite direction of its orbital velocity, which will obviously decrease our orbital velocity around Kerbin and will then return us back into Kerbal atmosphere. And that's, of course, if everything is correct. If everything is wrong, we're actually going the opposite direction, and we're possibly going to be on escape velocity away from Kerbin and leaving the system and orbiting around the Kerbal or the sun for the rest of our lives, which is also okay, but this is not what we planned. And of course, we're going to be blaming Bob for this because he looks very nervous and he looks like he's guilty. So let's look at this. This should be about just over 600 for us to escape. Possibly more than 600. I think it's actually more than 600. And then once this reaches about 800, this is when we should be able to cross with Kerbin. Alright, 870. Let's just increase this to 900 just to be sure, because we're not sure if this is enough for us to return. But I think this will definitely be enough, right? I think so. I hope so. Okay, let's hope that 900 is enough. As soon as we escape the moon, and this is definitely the higher than escape velocity of the moon, we're going to try to see if we can at least pass by periapsis of Kerbin, and then if we get there, we'll be able to try to calculate how much more we need to decrease this by for us to return back home. All right, Bob, you look happy, and that's because I have good news and bad news. Good news is that it looks like we've calculated this relatively correctly, and it seems like we're approaching Kerbin. We're going to be using the altimeter to see if it's just periapsis or if we actually are going to be landing on Kerbin. But the good news is that we are going home. The bad news is that this will increase to about 3,000 meters per second. So we have to be ready with our heat shield. But as you can see, we are approaching Kerbin, and I can tell that we are approaching Kerbin because not only is it increasing in size, but this altimeter is going crazy. It's decreasing very, very fast. So this means that we are moving toward Kerbin really fast. Now, we're not going to release our last stage just yet, but you know what? It looks like we might be entering Kerbal atmosphere. Just judging by the way it looks, we'll be passing through the atmosphere, meaning that we can possibly slow down using it, but we'll only find out if this is what's happening once we reach the periapsis here. And the only way if we can do that is just to wait. And if we are actually entering Kerbal atmosphere, we're going to release our last stage, get rid of the engine, and then face ourselves in a descent mode so that we can use the heat shield to slow down, because without the heat shield, we're not unfortunately going to survive this. So we do need the heat shield to try to live through this mission. And we have 4 parachutes for a safe descent afterwards. And if we're actually entering this area, it looks like we'll be landing on land, possibly in the mountains. And current velocity is 3,200 meters per second. Okay, yes, this is atmosphere 70 kilometers. Release the last stage. And we're going to position ourselves toward our retrograde velocity. And just wait. So here comes the burning. And the heat shield will hopefully protect us. Okay, Bob, hold my hand. Let's make sure that we'll survive this. Okay, here comes the burn. Here comes the heat. The speed is still really high. And we can only release the parachutes at a speed of about under 300 meters per second, which means that we need to really wait for a long time. Let's see if I can position myself so I can actually see the Earth or Kerbal. I want to be able to see the ground. Here we go. Oh, that is not good. What was that? That was a bad sound. Hopefully that was not something... Hopefully that was not a parachute. Oh, I really hope that wasn't a parachute. We may have lost one of the parachutes. But we are definitely decreasing in speed, and the heat shield is definitely doing a good job. The altitude is under 20 kilometers. And the radar altitude is still not showing, so that's a good sign. 1500 meters per second. I wonder how many parachutes we lost. I heard at least one explosion, possibly two. We need at least 2 parachutes for a safe descent, though. Okay. Burn is finished. We're now going to be descending safely, hopefully safely, into the atmosphere. We're still above 4 kilometers. And alright, so we're at a safe speed. And we're gonna wait for at least or just under 200 meters per second before we release the parachutes, because it's better be safe than sorry. Plus we can still use the atmospheric pressure to decrease our speed up until about an altitude of about 1 kilometer. So here we go. Here comes the radar altitude. And now, okay, I heard at least one parachute. Is it one? Is it just one? Oh boy. No, yay, it's gonna be safe. Excellent. 6 meters per second. So that was good. That was actually well done. Looks like we are going to be safe, returning safely back home. And it looks like this mission was a success. So this manually controlled ship was able to return back to Kerbal using nothing but mathematics and the knowledge of Kerbal space program and the Kerbal system as well. So all we needed for this is... So all we really needed for this is are the formulas I showed you, and of course a little bit of mathematical calculation and a little bit of knowledge of how spacecrafts work. And it looks like we're descending relatively safely at a speed of about 6 meters per second. I think there's one parachute missing because we're a little bit tilted. And we can see the features on the surface already. So that's a good sign. It's going to be a pretty safe descent and everyone's going to return home safely. And we have 100 meters to go, and here comes the surface. We're almost home. Everyone is really excited about this, especially me, I think. Bob is not so happy. I think he liked the moon better. And here comes the landing. And now. Excellent. All right, let's get out and see what's up. Looks like we actually may have not lost any parachutes. But let's just get down and take the last look at our beautiful planet. Before we take the last selfie and say goodbye to all of you beautiful viewers, and thank you so much for watching. And if you've enjoyed this video, check out some of the other Kerbal Space Program videos I've posted, and also make sure to check out the other videos from other space video games that I made as well. Like this video and share it with your friends if you've enjoyed it. And if you have any questions about the math involved in this video, or if you have any other comments or suggestions, please let me know. And I think in one of the future videos, we're going to use something similar, using manual approach to try to maybe do something a little bit more difficult, possibly even reach other planets if we can. It's going to be really hard, and I may have to use some mods. For example, I have to actually possibly use a better navball mod, because using my smudgy navball was really challenging. But if you do have suggestions, let me know. Thank you for watching, and game you later, guys, and bye-bye.